In this video, we are discussing the various reaction-based questions in the CBSE board exam. And this is 2020 set 5. I've gotten this paper from IIT in chemistry, iitnacademy.com. And you can check out the website for the other question papers as well. And it's super helpful. So first one is question number 13. So here you have CH3CONH2 reacting with sodium hydroxide and bromine in alcoholic medium. So question 13, and we need to figure out the product that is formed. So CH3CONH2 reacting with sodium hydroxide and bromine in alcoholic medium. And this is actually Hofmann-Bromamide reaction. So the product of this is going to be, so this CO gets removed, give us CH3NH2 plus Na2CO3, NaBr, and water. So the product we are most concerned with is the CH3NH2, which is option number 3. The next question is question number 31. So here they have asked us to figure out what A, B, C, D, E, and F are. So the thing is, when you look at something like this, it automatically might overwhelm you. So what I would suggest is, let's break this down. First, we are going to be considering this reaction, that is this one, where you have the formation of A, B, and C. So first of all, a reactant is CH3, CH, CH2, Br, and the CH is attached to a CH3, or a CH3 is attached to the CH. So this is undergoing a reaction in the presence of alcoholic KOH. Now, this is a reaction from haloalkanes and haloarenes. Alkyl halides will undergo elimination, and this leads to the formation of an alkene. So Br is going to get removed along with a H. So HBr gets removed, and this leads to the formation of an alkene. And over here, our major product is obviously going to be the one here. Like there's only one product that's possible. So CH3, CH, oh, sorry. CH3, oops, CH3, C, then you have another CH3, double bond CH2. So this is the alkene that is formed. Now this is undergoing a reaction with HBr. So again, it's the first you are removing a HBr, now we are again reacting it with HBr. And this will react based on the Markov-Nikov's rule, which states that the negative part of the reagent will get attached to the carbon atom having less number of hydrogen atoms. So here between this carbon and this carbon, that is carbon number 1 and 2, considering based on just randomly, it's not based on the nomenclature. So the first carbon has less, like basically no hydrogen atoms. So the bromine will get attached to that carbon. So the product over here is going to be CH3, C, CH3, Br, and another CH3. Okay, now this particular compound is undergoing a reaction with sodium in dry ether. And this is basically Wood's reaction. Wood's reaction, I'm pretty sure you know what, the basic reaction for Wood's reaction. So I'm going to just write the product, that is CH. And moreover, we have discussed Wood's reaction in the previous set of videos. So the product is CH3, C, C, CH3, CH3, so basically you have the sodium and dry ether that's formed, right? Sorry, that is undergoing chemical reaction. And then I do check out the video on Wood's reaction that I did. So basically this bromine will get kicked out and two molecules of this reacts, and the carbons which were attached to the bromine will form a bond. So in this reaction, this is A, this is B, this is C. So we're done with one part. The second one is D and E. So let's take the reactant again. So CH3, CH, CH2, Br, and another CH3. Now, this is undergoing a reaction with magnesium in dry ether. Now, this leads to something called as the formation, like it leads to the formation of the Grignard's reagent. And Grignard's reagent's formula is going to be, so basically, it forms RMgBr. So this is the R group, this is the bromine, this is the R, and you have the magnesium getting attached in between them. So CH3, CH, CH3, CH2, Mg, Br. And this is the Grignard's reagent, and this is product D. Now, when Grignard's reagent undergoes reaction with water, it leads to the formation of a hydrocarbon, and that is what is going to happen. The MgBr is going to get kicked out, and this in turn is going to give us a hydrocarbon. So CH3, CH, CH3, I'm sorry, C2, 3. Oh, actually, 1 second. I forgot about the CH3 down there. So another CH3. So this is giving us a hydrocarbon with MgOH, Br. The last one, so this is E. The last one is F, that is CH3, CH, CH3, CH2, Br, CH3, reacting with NaOC2H5. Now, when I was preparing my notes, so basically what I do is I take just the textbook. I'm just using the textbook to solve these questions. And when I was trying to solve this one, it was actually quite difficult for me to do it. And then I realized the answer was in the table all along. So this particular reaction is actually the nucleophilic substitution reaction. When the reagent is NaOR dash, it gives us ROR dash, which is an ether. So we get an ether from this particular reaction. So here you have CH3. So let's just say RX plus NaO R dash going to give us RO R dash plus NaX. And this is the nucleophilic substitution reaction. So CH3, CH, CH3, CH2 is going to form a bond with the oxygen atom that's here and C2H5. This is the product F. So that's it. That's how we solve question 31. Next, we'll be solving question 32. Before that, let me just quickly erase all of this so we have some space to solve it. So we need to give the structure of the final products which are formed when hydroboration of propene followed by oxidation with H2O2. Now, what we are seeing is, first of all, the reactant, 32. So the reactant is propene, is undergoing hydroboration. And this particular product which is formed is undergoing oxidation with H2O2, hydrogen peroxide, in alkaline medium. So first of all, the hydroboration reaction, basically this is a reaction from alcohols, phenols, and ethers. So CH3, CH, double bond CH2 reacts with HBH2 taken twice to give us CH3, CH, CH2, BH2, and this further undergoes a chemical reaction with CH3, CH, double bond CH2 to give us BH, CH3. Actually, let's do it the other way around. So this particular reaction is actually one of the methods of preparation of alcohols. So we get CH3, CH2, CH2 taken twice, BH, and this undergoes a chemical reaction with another molecule of CH3, CH, CH2 to give us CH3, CH2, CH2 taken thrice, B. Now, this is the first part, that is hydroboration of propene. Now, this is followed by oxidation using hydrogen peroxide. That is the last step where it leads to the formation of an alcohol. So H2O, H2O2, 3H2O2 gives us an alcohol that is CH3, CH2, CH2OH. That's it. So this is the direct reaction of the formation of the synthesis of alcohol. This is just given in your textbook. You just need to realize that the hydroboration is basically reaction of propene with HBH2 taken twice. The next one is a reaction. So here you have the dehydration of CH3, taken thrice, COH, by heating it with 20% of H3PO4 at 358 Kelvin. Now, this particular reaction is obviously also from alcohols, phenols, and ethers. And this is a dehydration reaction. So tertiary alcohols undergo dehydration in the presence of 20% H3PO4 at 358 Kelvin. So you have CH3 thrice, COH reacting with 20%, sorry, 20% H3PO4 and at 358 Kelvin. This gives us this leads to the loss of the OH and gives us a double bond between any of the two carbon atoms. So C double bond. That was bad. And this is a dehydration reaction. So double bond CH2, CH3 plus water. And tertiary alcohols, as we know, undergoes dehydration reactions quite easily. The last one is heating this particular molecule, which is an ether, with HI. So let's quickly write the molecule down. CH2O. Now, this is basically the cleavage of CO bond in ethers. Now, when you have, so when this particular reaction takes place, that is in presence of, is getting heated, so HI and heat. And this leads to the formation of alkyl halide, that is CH2I and a phenol. So in case of phenols, it doesn't give us an alkyl halide because it cannot undergo nucleophilic substitution reaction. So the OH will not get kicked out to give us an aryl halide. One more very interesting point is the fact that this is actually an indexed question that is given in your textbook. No, an example question, and it's 11.7. So again, very important for you to remember to go through the in-text questions, the example problems as well. The next one is question number 32, the OR part of it. First one is we need to convert phenol to orthohydroxy benzaldehyde. So you have an aldehyde group, CHO, and an OH. Now, how do we do this? This is actually the Riemer-Tiemann reaction. So when you have phenol, this reacts with CHCl3. I think I vaguely remember having this particular question in my board exam as well. I guess, I think so. I don't know. I should go back and see, but I vaguely remember having to write this. So we get O minus Na plus because of the sodium hydroxide. And we have CHCl2, and this is the intermediate that is formed. This reacts with another molecule of sodium hydroxide to give us the aldehyde. And the O minus Na plus stays the same. However, this undergoes another reaction with H plus to give us the final product that we needed, that is the orthohydroxy benzaldehyde. This is the Riemer-Tiemann reaction. The second one is methanol to ethanol. So we have methanol. Let's write the formula. That is CH3. Oh, no, sorry. Ethanol is not CH3, it's HCHO. So HCHO needs to get converted to give us CH3, CH2, OH. So CH3, CH2, OH. Now, how do we do this? This is done by using the Grignard's reagent. And this is one of the methods of preparation of alcohols where you have an aldehyde group reacting with RMgX to give us an intermediate adduct, which is CR O minus Mgx. This undergoes reaction with H2O to give us COH R plus MgOHX. So this is the Grignard's reaction. Now we have HCHO. So HCOH reacts with, it needs another atom of carbon, CH3 Mg Br in the presence of water should give us CH3 CH2 OH plus MgOH Br. So this is just the basic reaction of synthesis of alcohols from aldehydes using the Grignard's reagent. The last one is reaction conversion of phenol to phenyl ethanoate. Now, phenyl ethanoate is obviously an ether which has a phenyl group on one side and an ethyl group on the other side of the oxygen. So if you know at this point, I'm pretty sure you figured out the method. This is probably one of the methods of preparation of the ether. So third one, phenol to OCH2 CH3. This is the product that we need. Now we can easily use Williamson's synthesis where you have Rx plus R dash ONA gives rise to ROR dash plus NaX. Now, it's easy for us to convert the phenol OH group to an O minus Na plus by reacting it with sodium hydroxide. And this gives us benzene with O minus Na plus. This reacts with Rx, which is C2H5 Br, to give us the phenyl ethanoate. That's it. This is the Williamson synthesis. The next one is question number 36. Here, question number 36, we have A, and we need to solve the A of the odd question as well. So we need to write the products formed when benzaldehyde reacts with the following reagent. So benzaldehyde, we quickly write the formula. CHO. This undergoes a reaction with CH3CHO in the presence of dilute NaOH. At this point, I'm pretty sure you know when dilute NaOH is involved, it is the cross-aldol condensation. And because you have another aldehydic molecule, it's a cross-aldol condensation. So benzaldehyde reacts with CH3CHO in the presence of dilute NaOH to give us the cross-aldol condensation product, which is 3-hydroxy 3-phenyl propanol. Now, one more important thing, I know it's sometimes quite difficult for us to solve the aldol products. So I would suggest for you to revise how the aldol condensation products are written in the first place. So the product for this reaction is this, which is and since they've not mentioned the loss of water, we're not considering the second part. We're not removing the water because of the absence of the H plus. So this is the product which is formed. This is the cross-aldol condensation product. The next one is benzaldehyde reacting with this. Now, as we know, this is a nucleophilic addition reaction. So when you have a nucleophilic addition reaction with an amine, basically when you have an aldehyde, C double bond O, reacting with NH2Z, this gives rise to an adduct. Actually, it's an intermediate rather, COH, and this side it'll be NHZ. And this in turn is going to give us C double bond NZ plus H2. This is the product formed. So here you have the benzaldehyde, that is CHO, reacting with NH2, NH. Okay, now this leads to the formation of this particular molecule where you have the benzene, okay, C, H, O, 1, 2, 3, 4, 4, right? Yeah. And then the carbon is also forming. So the double bond, actually, you know what, I'm just gonna. So the hydrogen, the double bond between the carbon and the oxygen breaks for us to have OH and NH, NH. And this in turn is going to give us a double bond between the carbon and the nitrogen. So this is the nucleophilic substitution reaction, sorry, nucleophilic addition reaction that aldehydes have undergone. The third one is with concentrated sodium hydroxide. So this is the Cannizaro's reaction. You have CHO reacting with concentrated NaOH on heating. This gives us benzyl alcohol, that is CH2OH plus sodium benzoate. It's a Cannizaro's reaction. It's the name reaction. That's it. The last one is we need to write the final product for these reactions which have been given. The first one is you have an aldehyde. Okay. Oh, sorry. It's a ketone. So when it reacts with ZHG, that is a zinc amalgam, this is the Clemenson's reaction, reduction rather. And this leads to the formation of the removal of this double bond O. So we'll get a hydrocarbon, CH3, CH2, CH3 plus H2O. That is Clemenson's reduction. The second one you have sodium benzoate, if I'm not wrong. Yeah, sodium benzoate. And this is undergoing a reaction with sodium hydroxide and calcium oxide. This is a decarboxylation reaction. So the COONA will get removed to give us benzene plus Na2CO3. And the last one is reaction with dibyl H. And this is basically the preparation of aldehydes from nitriles and esters. And the dibyl H does not remove the double bond. Instead, it only acts on the cyanide group to give us a CH2 double bond CH, single bond CH2, CHO. And all of these questions are based on the chapter aldehydes, ketones, and carboxylic acids. With that, we're done with solving the various reaction-based questions for from the 2020 set 5. Do let me know if there's if there's a clarification, or do let me know if you need something else that needs to be covered.